Okay, so question 56 is a correlation or a corollary to the last problem 55. And instead of asking you to draw the resonance forms, it's asking you which species is the stronger base. So keep in mind the stronger base, everything else being equal, is going to be the atom that has the highest electron density on it. So in these cases, we're comparing apples to apples, right? So we have carbon on both of these and nitrogen on both of these. So if you have everything being equal, you're not going to have, in these cases, you're not going to have a huge difference in steric hindrance by the rest of the molecule. So because we have very little structural differences, we can compare electron density directly. So what we're saying is that the compound that has the most electron density is going to be the stronger base. So for the same reasons that the molecule on the right is going to be the more stable compound, because you can actually do this kind of resonance, whereas on the molecule on the left you can't do this. So because you can do this resonance for the molecule on the right, that negative charge and that electron density is not always residing on this carbon. It's partially residing on this carbon and it's partially residing on this oxygen. Versus, the compound on the left, where you have that negative charge is completely centered on that carbon. It can't go anywhere. So this carbon on the left, for this molecule on the left, is going to be way more basic than the molecule on the right. Okay, so because you have no resonance forms here, this is going to be a stronger base. So a stronger base. Okay, and it's as simple as that. So for the same reason that this molecule on the left is more stable than the molecule on the right, okay, molecule on the left is very stable, molecule on the right you can say is relatively unstable. The molecule on the right is going to be a better base. And this kind of makes sense intuitively. If it's less stable, it's going to be better able to act as a base. More stable, it's happy as it is, doesn't really need to interact with anything else. So molecule on the right, because you only have one resonance form, you have a lot more electron density on this nitrogen. It's going to be a lot better suited to pick up a proton, whereas the one on the left is not going to be as suited to pick up a proton. Okay, and again, it's the same rationale. You have this dispersion of electron density. The electrons on the nitrogen aren't always there. They're kind of residing on the nitrogen, kind of residing on the oxygen. Okay, so the one on the right, in this case, is the stronger base for the same reason, whereas before the molecule on the left is the more stable molecule, because molecule on the left has resonance, molecule on the right does not have resonance. And it's as simple as that. Okay, so stronger base right there. Very simple.